Hello, today I'm going to be explaining quadratics. So, quadratics, they come in three forms, and I'm going to go over each of them. So, there's a standard, factored, and vertex form. So, first, starting with standard form. It's the most common form. It appears on most of your math tests. So, first, we have the first coefficient, or a. It's just dragged down whenever you're converting into factored form, which is what you're most of the time wanting to do with standard form. Next, you have their roots. So the roots add to the b, or the second coefficient, and multiply to the constant, or c. So to give you an example, if it's x minus 4 and x minus 3, they would multiply to c. So c would be minus 4 and minus 3 is equal to 12. And b would be added, so minus 4 plus minus 3, which is minus 7. And so basically you can use this to figure out the b or the c value, or you can use the b and the c values to figure out the roots. Next, we have some nice tricks you can do with all this information. So minus v over a will always equal the roots added together. So for example, if you had the earlier equation, we remember b was 7, minus 7. So if we have minus b, it's going to be minus 7 over 1. And that is going to equal positive 7. If we remember, we had x minus 4 and x minus 3. So to get our zeros, our solutions, or our roots, what we have to do is set them equal to 0. So it would be x equals 4 and x equals 3. And 4 plus 3 just so happens to be 7. So these two will always be the same. Next up, we have c over a is the product of the roots. If we remember, our c was 12, and we're just assuming our a is 1. So 12 times 1 is just 12. And remember, 4 times 3 is 12. Next, we have this thing called the discriminant, which is b squared minus 4 times a times c. You can use that to determine how many real solutions there are. We'll go into that later. And finally, over here, we have the quadratic formula, which you can use if you can't factor it properly. All right, next, some examples for factoring. So x squared plus 15x plus 54. So looking at this, we know that they have to multiply to 54 and add to 15. So we can look at multiples of 54, and the first one, I and a lot of other people probably can think of, are 9 and 6. And 9 plus 6 just so happens to be 15. So over here, we'll have x plus 9 and x plus 6. And there we go. And so if we want to figure out the roots or the zeros of this, so where are the x-intercepts, it would be x equals negative 9 and x equals negative 6. All right, next we have 6x squared plus 16x plus 8. You can see this one has an a value that's greater than 1. So what we're going to do is first we can notice that everything here is divisible by 2. So what we can do is take out a 2, and then it becomes 3x squared plus 8x plus 4. And so the thing that you do whenever you have a 3x here is you can just make the parentheses and have one of them be 3x. And so the way this 3x works is that you have to multiply this 3 to the 4, and so they have to multiply to 12 in actuality. So a good thing that you can do with this is just x plus 2 over here and 3x plus 2 over here. So this 3 will multiply to this 2. That's actually a plus 6, and this is a plus 2. And 6 plus 2 is equal to 8. So this equation works with this. And obviously when you have the 3x plus 2 and then the x plus 2, x is going to equal negative 3 over 2, and x is going to equal negative 2. Alright, now we're going to look at the sum and product of the roots. So over here we have another equation that can be simplified. And all of these things are divisible by 4. So we're going to have 4, 2x squared minus 6x plus 25. Alright, and then if we're looking at the sum of these roots, so minus b, so that's minus 6 over a, which is 2. So minus minus 6 is just positive 6, and the a value is 2, so it's going to be 6 over 2 or 3. The sum of the roots of this equation will always be 3. Of course, the actual solution for this has I values, or imaginary numbers, but the actual answer at both roots or x-intercepts will add up to 3. Well, it doesn't have any actual x-intercepts, but the imaginary x-intercepts will add up to 3. Alright, next up we have the products. So this one is pretty simple. It's just c over a. So c is equal to 8, a is equal to 2, so 8 over 2 is 4. The product of the zeros to this equation are going to be 4. You can notice that I've been writing solutions, zeros, roots. All of these are used interchangeably, so you have to make sure you remember solutions, zeros, roots, x-intercepts. All of those can be used pretty interchangeably, but like the mistake I made earlier, x-intercepts can't be imaginary numbers. Alright, now we are going to look at discriminants. So if you remember, we have the b squared minus 4ac part of the quadratic formula. So if we're going to take a 2 out of this, well actually we take a 4 out of that. So let me just take a 4, it's going to be x squared plus 4x plus 4. Alright, so b squared, which is b is 4, so it's going to be 16 minus, and then we have 4 times a times c, so that's going to be another 4, which is equal to 16. So then we're going to have 16 minus 16 equals 0, and if the discriminant, or b squared minus 4ac, if it's equal to 0, that means we only have one real solution. So it's asking how many real solutions? Well, we're going to have one real solution. If it's greater than 1, if it's greater than 0 or 1, then it's going to be equivalent to 2 real solutions. And if it's less than 0 or a negative number, then it's going to be no real solutions. Alright, back with this one. We're going to divide by 2. Next, we're going to have the 3x squared plus 8x plus 9. Alright, so b squared, so that's going to be 64, minus, and then that's 4 times a times c. It's going to be 4 times 27, which is going to be 108. Sorry, I just had to use my calculator for that real quick. Alright, and then we know that 64 minus 108 is going to be a negative number, negative 44 to be more specific. So that means that the amount of real solutions that exist for this equation are 0. There are no real solutions for that quadratic equation. Alright, next up, factored form. Factored form is the thing that you turn the roots, and that contains the roots that you turn standard form equations into. Whenever you take both the roots and divide by 2, you can find the x-coordinates of the vertex. So for example, if it's x equals, let's say 6, and x equals 2, you can do 6 plus 2, which is 8, divide by 2. You'll get 4, so that means you know the vertex is going to be a 4 and then some y value. However, that's pretty much the only use for factored form that I can think of. And so yeah, it's pretty useless, just like a certain anime character here. Alright, finally we have vertex form, one of the more meaty forms of this. So, vertex form has the a value, the first coefficient that we spoke about earlier, and then it has x minus h, where h is the x value of the vertex, but remember it's minus here. So for example, if it's x minus 3, the vertex will be located at an x value of positive 3. And then we have a constant over here, which is going to be the y value of the vertex. So let's say 8. That means k is also 8. That just directly translates up there. So the main use that you have for vertex form is going to turn it into this equation, which just adds a b over here, which you can use in order to determine transformations of quadratic functions. So if the a value is changed, then you change the vertical stretch or compression of it. So for example, if the a value is 1/2, that means it's a vertical compression of 1/2. If the b value, on the other hand, is a 1/2, the b value is reversed, so that's going to be a vertical stretch of 2. And then switching it around, if the a value is 2, then that's going to be a vertical stretch of 2. And sorry, I said b was vertical earlier. It's actually horizontal. And let's say the b value is 3. That's going to be a horizontal compression of 1/3. Alright, next up we have left and right shifts. So C is kind of like that H where it's a negative value, so it lies. So for example, if the inner part of this is going to be x minus 3, then it's going to be shifted right 3. Whereas if it's x plus 3, then it's going to be left 3. And just like the initial vertex form equation, D controls if it goes up and down. So if D is 4, then it's up 4. It doesn't lie or anything like that, so it's one of the easiest ones to read. Alright, so now what we're going to do is create a quadratic by using the transformations that we know. So we know that it's going to be A, and then B, x minus c squared plus d. Alright, so we know that the initial thing we want to do is stretch by 2, so that's just going to be changing the a value to 2. Next up, we're going to horizontally compress by 1/6. So we know that this lies, so if we want to compress by 1/6, that means we need to put a 6, not a 1/6. So we're going to put a 6. Next, we're going to go right 5. So it's going to be x minus 5, because we have to remember that it lies, so minus 5 is actually going to be 5 to the right. We're going to end that. And shift up 4. It's going to be a plus 4 over here, and that doesn't lie or anything like that, so it's just a plus 4. Next, we're going to reflect about the x-axis. So the x-axis is a vertical reflection, and the y-axis is a horizontal reflection. So if we want a vertical reflection, we just make this a negative number, and if we wanted a horizontal reflection, we would make that a negative number. But we don't want a horizontal reflection, so that means negative 2, and then a 6 on the inside, x minus 5 squared plus 4 is our final answer for this quadratic equation, assuming the parent function is y equals x squared, which it will always be unless it's specified. And that is it for this Quadratics Explained video. I hope you enjoy and have a great day.